Solving systems of equations, word problems. In this video, I have 4 sort of typical word problems where we need to set up a system of equations before we can solve it. So, the first problem, suppose we have a hospital that uses a 10% bleach solution to disinfect an area. How much 8% bleach solution must be mixed with a 20% solution to make 60 liters of a 10% solution? Now there's a lot going on here. So when doing problems like this, it may be very helpful, and I highly recommend it, that we label things and tell ourselves at least what's going on. So I have 2 solutions. I have an 8% bleach solution and a 20% bleach solution. So I'm going to call X the 8% bleach solution. And then I will call Y the 20% solution. Now, bleach solution, I just left off the word there. So I like to label things very explicitly to help me set problems up. Since I have 2 unknowns here, I need 2 equations. So what 2 equations could I make? Well, I could say the amount of the 8% solution, right, plus the amount of the 20% solution must equal 60 liters. There's my first equation. And then the second equation I'm going to write is going to look similar, but it's a slight difference. So it's going to be the amount of bleach in the 8% solution, and I'll just put in the 8%, plus the amount of bleach in the 20%, must equal what? Well, it must equal the amount of bleach in the 10% solution. So I have total amount of solution plus total amount of solution equals total amount of solution. And then the amount of bleach plus the amount of bleach equals the total amount of bleach. So given this, and how I define X and Y, I can write 2 equations. The first equation gives me X, the amount of 8% solution, plus Y, the amount of 20% solution, equals 60 liters, or simply 60. Now, how much bleach is in the 8% solution? Well, I have 0.08 times how much of that solution I have, and then 0.20 times how much of that solution I have, so 0.08x plus 0.20y equals the amount of bleach, 10%, of the total amount of solution. Now we just solve this one like we would normally do. Let me rewrite this bottom one, 0.08x, just simplify it a little bit, plus 0.20y equals 6. And then I could solve like this, but I'm going to multiply this by 100 just to make it a little bit easier for me to deal with. So I'm going to have x plus y equals 60. That is, I'm rewriting this equation. And then I'm going to multiply this equation by 100, so 8x plus 20y equals 600. And now we need to solve this one somehow. I like to use elimination. And I'm going to multiply this first equation by -8 and then add the two equations. -8x plus 8x gives me 0x. I have eliminated the x. -8y plus 20y gives me 12y. -8 times 60, or -480, plus 600 gives me 120. If you need to see that top one over here, I'll rewrite it really quickly for you. And I would add it with the second one. And that gives me this equation, which says that y equals 10 liters to be specific. And since x plus y equals 60, I have x equals 50 liters. So I would use 50 liters of the 8% solution and 10 liters of the 20% solution to get 60 liters of a 10% solution. Let's look at another type of problem. Consider a boat traveling at a constant speed against a river's current. It takes the boat 6 hours to go 36 miles. Traveling with the current, the boat takes 3 hours to go the same distance. So, for example, if this is upstream against the current, it takes the boat 6 hours to go that direction, but with the current pushing it, it only takes 3 hours to go back. Given this, what is the speed of the boat and what is the speed of the current? Quick note, distance equals speed times time. We'll see why I need to use this in just a bit. So let's define a couple things. In this case, I'm going to let B equal the speed of the boat. And I'll let R equal the speed of the river, or the speed of the current. And I want to set up two equations. Well, I have two pieces of information. I have that it takes, 36 miles, I should say. I go 36 miles in 6 hours. When I have the speed of the boat minus the speed of the river. Now, where does that come from? Why do I have this equation here? What does that mean? The speed of the boat minus the speed of the river. So if I go back into my picture up here and try to look what's going on, notice that in this direction, I have the boat when I'm up top. I have the speed of the boat going this way, but the speed of the river is acting against it. And so overall I get a total speed, which is a combination of the boat trying to go this way and the river trying to go this way. How about on the way back? We still go 36 miles, and it takes 3 hours. What do you think I should put for the overall speed of the boat? Well, I have the boat's normal speed, right? So now going backwards, I have the boat's speed going this way. But then I also have the river pushing it and adding on to the overall speed of the boat. So I used this equation to come up with these two. I rearranged it. I really wrote distance equals time times speed, just in case you were wondering what I did. So I have the distance equals the time multiplied by the overall speed, the boat trying to go in one way and the river acting against it. But on the way back, I have the overall time, and then the overall speed as well, where the boat and the river are getting pushed along in the same direction, or more specifically, the river is helping push the boat along. So we have two equations now. All we have to do is solve these two equations. I'm going to rearrange the order. I get 6b minus 6r equals 36. And then 3b plus 3r also equals 36. All right, so how can I solve this one? I think I'm going to eliminate the r's, and I'll multiply this bottom row by 2. So I'll rewrite the top row. 6b minus 6r equals 36. And the bottom row, I get 6b plus 6r equals 72. When I add those together, I get 12b equals 108. Or the speed of the boat B equals 9, and I didn't put units, but kilometers per hour, or whatever it happens to be. Now I need to solve for the R. I will plug it back into this equation. That is, I'll let B equal 9 there. So I'll get 6 times 9 minus 6R equals 36. 54 minus 36 equals 6r, or 18 equals 6r, so r equals 3. Third problem. Consider a tree service company that has a fixed monthly cost of $400 and variable costs of $30 per service call. The company charges $50 per service call. How many of these services do they need to make each month in order to break even? So let's define a couple things. This problem is not as complicated as the other ones might be. I'm going to let R be the revenue, which is how much money they make. I'm going to let X equal the number of service calls. So how much money do we make? Well, R equals $50 per or times each service call. Now, let's define something else called the cost. I'll call it C. And I'll say this is the money spent. So what is my cost equation? Well, the cost is $400 plus $30 per or times every service call. So I have two equations, but I really only have one variable. How do I use this to solve what I need? The question asks, how many service calls do they need? What is the value of X? To make each month to break even. So in case you weren't sure, the break even point is when the revenue equals the cost. So we simply set our revenue equation, 50x, equal to the cost equation, and then solve. So we get 20x equals 400 after we solve 50x equals 400 plus 30x, and then x equals 20. So in order to break even, the tree company needs to make 20 service calls per month. Any more calls beyond that would be profit. one final example. And this one we're going to do with investments. Here, Kevin invests a total of $5,000. Some goes into an account that pays 3% interest per year. The rest goes into an account that pays 5% interest per year. Now, my initial question is, why didn't he simply put all the money in the 5% account? The answer to that will be a mystery. Let's just solve the problem as is. So the question is asking, how much does he invest in each account if he has $5,214 in his accounts at the end of the year? So let's define things again. Let X be the amount invested. And let's say in the 3% account. And so we'll let Y, or whatever letter you want, but I'll do X and Y. X will be the amount invested in the 5% account. And I'll just write that as 5% account, 5% interest account. Now I need two sets of equations again. From the way I define X and Y, hopefully it's obvious that X plus Y must equal 5,000. The amount in one account plus the amount in the other account must equal 5,000. Now, what do you think the other equation should be? There's more than one that you could use, as long as you set things up right. I'm going to use this one and see if you can figure out why I chose to do this, or why this makes sense. I could say that 0.03x plus 0.05y equals 214. Does that second equation make sense to you? Here's what I'm saying. I'm saying that I earned 3% interest on one of the accounts, so I got some interest from it. I, or Kevin, earned 5% interest on the other account and got some interest from that. And the total interest that he got was $214. So if you can agree with these two equations, then we can simply solve them. I'm going to rewrite over here on the right. X plus Y equals 5,000. I'm going to multiply the second equation by 100. So give me 3x plus 5y equals 21,400. And then you can solve however you would like. I'm going to choose to solve it this way, by multiplying the top equation by -3 and then adding the two equations. When I do this, I get -3x plus 3x, so my x's are gone. I get -3y plus 5y, give me 2y, equals -3 times 5,000, so -15,000, I'll put that right there so we can see it, plus 21,400 gives us 2y equals $6,400. Remember, y, which is 3,200, is the initial amount put in the 5% account. And since x plus y is 5,000, that gives us x is $1,800. That is, the initial amount put in the 3% account is $1,800.